Assalamualaikum warahmatullahi wabarakatuh. My name is Mirza. Our group is pleased to present our project proposal, which is My Smart Shelter, an integrated smart transit hub for urban Malaysia. This project explores the feasibility of implementing advanced bus shelter technology within the Malaysian public transport network. Currently, Malaysia faces a significant deterrent in the bus ridership due to the poor waiting environment. Our background research identified three critical gaps. First, climate hostile, with temperature exceeding 33 degrees Celsius. Second, a safety deficiency at the night for vulnerable commuters. And third, a persistent information gap regarding the real-time bus arrival. To address this issue, we have benchmarked two international success stories. The Xiongdong Smart Shelter in Seoul demonstrate the efficiency of enclosed climate control environment in increasing passenger satisfaction. Additionally, Italy iStop project highlight how solar power real-time sensor technology can significantly reduce perceived waiting times. By localizing this innovation, My Smart Shelter aims to transform Malaysia bus stop into safe, comfortable, and data-driven hubs, ultimately encouraging a model shift toward sustainable public transportations.
We go to the aim of the project. The aim to increase a public usage in Kuala Lumpur by improving the waiting experience, which is a key barrier to a public transport adoption. We upgrade a conventional bus stop into a smart transit hub that improve a comfort, safety, and access to information through a climate responsive design, smart monitoring, and also a real-time travel updates. This reduce a first mile friction, build a commuter confidence, and support a shift away from a private vehicles aligned with a National Transport Policy 2019 to 2033 and the National Energy Transition Roadmap 2023. The objectives are measurable within 6 months. We target 85. The objectives are measurable within 6 months. We target 85% users are satisfaction, a 20% reduction in a perceived waiting time, and improve a thermal comfort by making the waiting zone 3 to 5 Celsius cooler than outdoor peak afternoon condition. We also aim for a 25% increase in perceived safety, especially at night. For reliability and sustainability, we target 95% uptime for lighting and information display, a 60% of core energy demand supplied by on-site solar. Within 12 months, we aim for a 5% ridership increase at the pilot stop. The scope is a pilot in Kuala Lumpur at 3 bus stops within 1 corridor or cluster. Sites are chosen based on high passenger activity, heat and rainfall exposure, proximity, and key trip generators, and nighttime safety concern. The project includes comfort, information, safety, features, and solar battery power, plus installation, testing, maintenance, and evaluation. It excludes network redesign, fleet expansion, or schedule changes because the focus is strictly on waiting experience and first mile confidence. Thank you.
Hello and Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Mama Hafizi bin Adnan. In this section, I will continue our presentation with the literature review for the Smart Bus Shelter Seoul project, which focuses on findings from previous studies and successful implementation related to passenger comfort, real-time information, and sustainability in public transport. Previous study consistently showed that passenger comfort is a key factor influencing public transport usage. Research by Kim and Lee found the climate control bus shelter significantly improved the waiting experience during extreme hot or cold weather, leading to the higher passenger satisfaction. In addition, real-time passenger information plays an important role in shaping user behavior. According to Cavero and Dye, displaying real-time bus arrival information reduces perceived waiting time and uncertainty even when the actual waiting time does not change. This helps to build passenger trust in public transport services. Next, for this literature review part, from a sustainability perspective, studies highlight the importance of smart infrastructure in supporting sustainable and smart city development. Research by Gracia and reports from the European Commission show that integrating solar energy, digital display, and smart sensors can improve the energy efficiency and reduce environmental impact. Furthermore, successful implementation in cities such as Seoul and several European cities demonstrate that smart bus shelters are partial, effective, and well accepted by the public. To conclude, finding from previous research and provide a strong economic foundation for the Smart Bus Shelter Seoul project, supporting its role in enhancing passenger comfort, service reliability, and sustainable urban mobility.
For my first part is model of project. The vision of this implementation of project is the purpose is to innovate it and make it suitable for the use in Malaysia. And the mission of this project is to enhance the public bus user experience and increase the usage of public transport in Malaysia. For my second part is solution and approach. Is divided by aspect, Seoul model and Malaysia adaptation. The first aspect is climate. At Seoul, the weather is cold winter while Malaysia has a hot, humid and rainy season. The second aspect is cooling system. Seoul model has a heated system, while in Malaysia we will try to adapt to ventilation and cooling fans. The third aspect is energy efficient. The first is some model is based on grid base, while Malaysia adaptation will be moved to hybrid solar with grid. The last aspect is the location. Seoul model smart bus stop is put at dense urban street, while Malaysia adaptation will be put at urban and suburban. The solution is for the smart bus stop is the infrastructure design, safety installation, and smart technology system, which is IoT. My last part is methodology and implementation time frame. The first methodology is hardware component, which include solar panel, LED display screen, CCTV camera, temperature and motion sensor, and lastly, energy efficient lighting. Second is software and digital tools, which include GPS bus tracking software, mobile app, for example like MyRapid app, and lastly, data analytic for operator. And last is stakeholder involvement. The first involvement include local authorities for approval of infrastructure improvement. Second is public transport operator, which to make sure their public transport is always in maintenance. Second is implementation time frame, which is the first phase is we will planning and study this infrastructure, which will take duration of 2 months. The second phase is we will design the infrastructure and make an improvement for our country Malaysia, which will take 4 months. The third phase is we will install and test for the first time of our innovation, which will also take 4 months. And the last phase, after the evaluation, we will put a full deployment of this project, which will take 5 months.
My name is Salina. So for my part, I will explain the financial implications and benefits of the My Shelter project. So based on the financial analysis presents in the report, so the estimate total cost is around 285,000 ringgit. So this slide shows the bar charts of the cost breakdown for this My Smart Shelter project. So based on the chart, the largest portions of the budget is allocated to the shelter structure and followed by smart technology systems and solar and also the security component. So this indicates that the project prioritizes durability, technology integration and passenger safety. So the total estimated project cost is around 285,000 as discussed in the financial implications sections of the report. So for the next one, I will details about the cost of uh, my smart shelter project. So the table summarizes the major cost components including the site preparations, construction, smart systems, and contingency costs. The project is planned to be complete within 6 months. So with an estimated annual operation and maintenance cost is around 20,000 until 30,000. So overall, this cost structure supports the long-term benefits of the project, such as increased public transport ridership, reduced environmental impact, and improved traffic flow. So in the terms of benefit, the improved designs and smart features of My Smart Shelter are expected to enhance passenger comfort, safety, and accessibility. So studies discussed in the report indicate that improved bus stop facilities can increase the public transport ridership by appropriate 10 to 20%. So this higher ridership contributes to environmental benefits such as reduced carbon emissions and improved air quality due to fewer private vehicles on the road. So additionally, we can increase the public transport usage helps improve traffic flows, particularly during peak hours by reducing congestion and supporting more efficient urban mobility in Kuala Lumpur.
In conclusion, My Smart Shelter is more than just an infrastructure upgrade. It is a commitment to a modern, riot-centric transit ecosystem. By localizing Seoul Smart technology, we are successfully bringing the comfort and safety gaps that has long hindered Malaysian public transport. This project aligns directly with our national transport policy, promoting a sustainable shift from private car to the public buses. Our integrated approach combining climate control, AI-driven security, and solar energy ensure that urban commuting is inclusive, green, and reliable for everyone. As we move toward a pilot phase in Kuala Lumpur, we believe this scalable model will set a new standard for a smart city across Malaysia. Let us transform the way we move, making our transit system a source of national pride. Thank you.